Hello, this is Dr. Liu, and the subject of this video is math review again, and we have right angle triangles and sine and cosine functions. In the previous video, I discussed how to find lengths given two lengths of a right angle triangle. So let's recreate that situation here. We have a right angle triangle and A, B, and C. So given these two lengths, we can use Pythagorean theorem to find that length, or given these two lengths, we can find that length with Pythagorean theorem as well. So whichever two lengths that are given, we can find the third length. And I also discussed briefly how to find these two angles. Basically, two pieces of information, two lengths, for example, can determine everything about this right angle triangle. So in this video, I want to discuss you're given, say, one length, and then you're given one angle. So again, two pieces of information, and that should be sufficient to determine everything else. Except that we're just going to be more specific. We want to be given length C, the hypotenuse. And we want to be given angle theta, which is this angle here. And this has a lot of applications. For example, if C is a vector, and this angle C makes with the horizontal axis that points to the right, then we want to find out C's x component, horizontal component, and C's vertical component, and is a very practical application to find components of vectors, because we can add components together and we can find sums of vectors. So let's find out how to get everything else out of just these two, a hypotenuse and also this angle. So to start, we'll introduce the cosine again. So cosine of theta, this angle, cosine is adjacent over hypotenuse. The quotes is because that's just is a rule. It's not a fixed A or a B. It could be either. It depends on which angle we're concerned with. So we're concerned with this angle, then A is the adjacent, B will be the opposite. Okay, so this is the cosine is adjacent over hypotenuse. And in our example, the adjacent is A, hypotenuse is C. So now we know cosine theta is A over C. And if we multiply both sides with a C, then this side will only have A, and the other side will have a C multiplied to the this cosine. So we'll have C times, this is how I write times, that distinguishes it from an x. Cosine theta is equal to A. Alright, so this is basically how you can find one of the two lengths, missing lengths, using C and the cosine of the angle. So we can write it this way, as A is equal to C times cosine theta. Okay, so what about B then? We'll just introduce another sinusoidal function, sine theta, which is opposite. This also is just a rule, depends on which angle we're concerned, and over hypotenuse. And in this case, opposite is B. So B over C. And we can do the same trick. We just multiply C on both sides, and the right side will be only B left, and the left side has a C. So C times sine theta is equal to B. Or we can say B is equal to the C times sine theta. So now we actually found both lengths, the lengths A and lengths B. And we can also find this other angle if we want. Let's just call it something else, alpha, for example. Just another Greek letter. And we know that alpha is supposed to be 90 degrees minus theta, because they are complementary to each other, right? So let's have some examples how to do this on the right side. So we'll have an example of a vector. So this vector is in R, and we'll put a harpoon on the top to indicate it's a vector, and it makes an angle. Oops. Okay, so this amount, if we call this an x-axis, and we call this a y-axis, this amount can be called Rx, because that's how long the R stretches in the x direction, and this amount can be called Ry, that's how long R stretches in this dimension, and this angle we'll still call it theta. So we'll have some values, say R is equal to 10, just made it up, and theta equals, say, 30 degrees. All right. So our goal is to find Rx and also Ry. All right, so going back to the equations, so this side here is the Rx side. So we can just rewrite this equation. So we have Rx equals R cosine theta. And this R simply is the length of this vector. Alright. And we also have Ry. Ry is this vertical one, and that compares to B. So that B is equal to this hypotenuse times sine. Okay, hypotenuse is R sine theta. We'll be using this formally in vectors, but for now we'll just use them for this problem. So this Rx is 10 times cosine 30 degrees. We'll leave that. We'll calculate it with our calculator. And Ry is equal to 10 times sine 30 degrees. Okay, so let me pop up my calculator, which is Python, and we'll do some calculations. Okay, so let's get my calculator. This is again Python, so this is my official calculator. And Python doesn't really know all these functions unless I do this, import math. So now it knows all about math. Here's a trick here. See this tooltip says measured in radians. So the angle that most of these scientific tools, including your calculator, will be measured in radians unless you set it in degrees. So let's do this. In order to make it into degrees, all I have to do is in radians is to divide by a factor. So this is cosine 30 degrees, 0.866, right? So if you multiply 10 with that previous answer, which you can use an underscore to represent that previous answer, just like the in your calculator, you can use the ANS for previous answer. So that is our Rx, 8.66, and our Ry is sine, right? Math dot sine 30 degrees, and that converts it into radians, and we'll just directly multiply this by 10 in one step, and that's effectively a 5, right? So we'll get over here, dismiss the calculator. Here we have 8.66, and here's 5.00. All right, thank you.